A very good afternoon to one and all. Today, it's a day 3 of our online 5-day faculty development program. We are here with another session titled GIS-based spatio-temporal investigation of soil and water quality. We have with us Dr. Chandra Devi R. from Sri Krishna College of Engineering as our speaker. Now, I request Ms. Anna Joseph, Assistant Professor, Jyothi Engineering College, to introduce our speaker to the audience.
Good afternoon, everyone. It's my great pleasure to introduce today's esteemed speaker, Dr. R. Chandra Devi, Associate Professor in Department of Civil Engineering at Sri Krishna College of Engineering and Technology, Coimbatore. Dr. Chandra Devi is an accomplished academician and researcher with over 18 years of experience in both national and international institutions. She holds a PhD in Civil Engineering from Anna University, Chennai, where her doctoral research is focused on textile wastewater treatment using iron and nanoparticles and integrated electrokinetics for soil remediation. She brings her global perspective, having been a Felix Scholar at Oxford University, DAD Scholar at Karlsruhe University, Germany, and a research fellow at Cape Breton University, Canada. Dr. Chandra Devi has made significant contributions to environmental engineering, especially in areas of water treatment, nanotechnology, and geotechnical investigation. With more than 13 SCI indexed publications and granted Indian patent and a co-authored book published by Cambridge Scholars. She is also a recipient of several achievements, including Best Paper Award from Anna University, Engg Researcher Award, and has led multiple government-funded research projects on self-healing concrete, slope stability, and sustainable canal lining using sea construction and demolishing waste. We are here truly fortunate to have her with us today to share her expertise and insight. Welcome, ma'am.
Thank you, ma'am. Everyone is hearing me. Am I audible to everybody?
Yes, ma'am.
Okay, thank you, Anna, ma'am, for your wonderful introduction. Let me share my screen. I hope everyone is able to see this.
Yes, ma'am. The slides are visible.
Okay, right. So a very good afternoon to one and all present here. So myself, I'm Dr. Chandra Devi. As Ms. Anna informed, like I have a very good experience, especially in the research experience in the national as well as international level. Okay, so first of all, I would like to thank Ms. Surya, Dr. Alvin for inviting me for this presentation, especially on this 5 days FDP, online FDP. And the topic is really an important one at this time, because it's purely about GIS, and we hear a lot of people and a lot of technologies are now replaced with artificial intelligence, especially even nowadays people, they are not at all searching with Google, but they go for chat GPT, right? So we want everything quick answers, quick reviewing. So it's a good time to see what are the applications of this just in our civil engineering. So most of the works they have started a decade ago, but those were very smaller, and it was it's a gradual improvement. But if you see the various the tremendous changes is happening now, right? So let's start with today's topic is purely about just spatio-temporal investigation of soil and water quality. It's one of my research work, part of my research work. Let me start with the, I think you all gone through this through Miss Anna. Okay, the content of this presentation is about a few introduction about GIS and GIS application in civil engineering, then application of GIS in Coimbatore city. Basically, I'm an associate professor from an engineering college in Coimbatore. So I would like to highlight that. Just it's going to be a very simple one, simple update on that. Then we will see a detailed case study on GIS in real-time applications. Let me take you to the next slide. Okay, here you can see. So it's all about the introduction about GIS. I think you might have got some information about GIS, Geographical Information System. I think someone is writing on my slide. Do you want to highlight something? Is using my slides and they are doing underline. Okay, right. So you can underline on your screen, I think. Okay, let's start with this. So GIS is a powerful tool, right? So if you see GIS, it's Geographical Information System. So nowadays GIS become a famous or a fancy word, but people, they don't know what it all contains. But its main aim of this one is organizing some data, storing data. If possible, we could go for analysis and presentation of those data, either spatial or non-spatial. So that's the main objective of it. So let's go for the clear picture of it. So what you will use for a GIS? If I want to work with a GIS, what are things I need to know? So you need to have some data. Without data, you can't work with a geographical information system. So your GIS can be, you can work with a GIS on any kind of projects. It may be a traffic planning or traffic management or urban planning or water supply or wastewater treatment, anything, any kind of objective can be your part of it. And you need some data to work with GIS. Okay, then especially you need to have, and next important thing is your GIS software. Nowadays, you have so many softwares. Everyone must have heard about ArcGIS, since the participants must be from civil engineering. I hope so. So you all heard about ArcGIS, but ArcGIS is very costly. And if you go for a online mode, you might have heard a QGIS. So that's very open software you can access, and you can do a lot of functions similar to GIS. And you need some experts who work, you are able to work with the GIS software, and you need some hardware, like definitely you need a computer or some other equipments or instrumentations for data collection, other things. And there are some procedures that to be followed up. Okay. And here you can see the application of GIS. I told you, you can use GIS everywhere, like even in marketing, insurance, tourism, urban planning, navigation, mapping, business, and agriculture. So it's not limited to this, but it's just keeps on going. You have enormous amount of application using GIS. This is not a today's trend, but it started nearly 20 to 30 years back, but that time it was very limited. Even in our surveying subjects, we would have studied about remote sensing and GIS. So GIS was an introduction subject 10 years back, just one topic you will have. But now you might have separate subjects like remote sensing and GIS in civil engineering, like you'll be having all 5 units and covering all the topics. So you have enormous application of this GIS in nowadays, day-to-day life. Okay, so recently we went to a field visit to Coimbatore Corporation. So there, you all might have known Coimbatore city was planned as a smart city by Tamil Nadu government. And as a part of it, they are just started some work with the GIS, like they will be doing a water supply, like in a water supply board, especially in the Coimbatore Corporation. They wanted to have a 24/7 water supply, and they wanted to monitor all the pipelines, networks, meters, everything. So they wanted to make everything as an automated or real-time operation. So they have this project and it's undergoing, it's in progress. And they were explaining this one very well. You could see some colorful pictures over here. Okay, right. What all they will do, like they will prepare some just base map and they will study the topographic thing on the study area. And what are the existing pipelines, like pipelines or infrastructure and land use of those things that would be detailedly studied. Then they go for a map generation. Then not just simply by data generation, you have to verify the data with your like a field survey as well. So they will connect the data. As I said before, there should be a proper collection of data should be there. So the data, then mapping, then further details like topography survey and aerial images, satellite images, all will play an important role. So those things would be like connected, and they have done all details and they generated maps, and they studied the network clearly, and they are just in a position of like supplying water on the Coimbatore city, like active supply, like 24/7. But whatever the inactive supply area, where are the laggings and where need to be updated, they are also taking consider those things in their mapping and things. So these are all as a part of the Smart City Coimbatore Corporation project. They are doing this one especially for water supply 24/7, like water supply management and monitoring. This is happening now. Maybe after 6 months, I think in everyone's home, we all will get water supply and everything will be monitored in a centralized way. But they are using for this one a GIS-based applications. Okay, let's move on to today's topic. So you all knew about what is GIS, what are the applications, and what are the trend nowadays. Let's start with a few introduction about the case study. It's going to be a pure case study. If I say everything in a generalized manner, the application won't be remember for you. And also you can utilize this basics for your projects. That would be really helpful. Okay, this one is purely about, you all heard about Coimbatore city is a very well known about clothing experts. Yeah. So our top 3 experts are from textiles. The first one, world level, China ranks first in European countries, and third is our India. This is global market share. And in India, if you look into the government manufacture, you see 40% in this districts, like you see the green color, the highlighted one. We have a highlighter here. I don't find anything. Okay, just I want to show you this one. So the 40% from Tamil Nadu and 31% from Gujarat. And yeah, I have some note. I can show you here. Yes. So one second, let me choose the color. It would be easy for you to check. Okay. Okay, right. So you see here, this is 40% in Coimbatore, especially Thrissur district. And this one 31% from Gujarat, and other like in like Andhra and Maharashtra, like it is spread evenly spread, but the maximum, if you see, it's highly concentrated in Thrissur district. If you look into the graph, the Thrissur district that plays a major role, it's a textile hub. 90% of our country's cotton knitwear exports are happening over here. If you look into the trend in 1985, if you see the expenditure or maybe the export level of that was very less. If you see, it's 18.69 crores. Everything is here in crores. And if you see even just a decade ago, it is like 26,000 crores. So you can see the tremendous improvement in the just last 20 to 30 years. You see the trend is highly increased in case of textile manufacturing. Okay, you all know about textile manufacturing. Let's see this one. So what actually textile manufacturing deals with? If you look into them detailedly, we have a processing like dry processing and wet processing. So dry processing, what they will do, like they don't need any water in case of preparations. Like the natural fibers will be collected and it will be spinned and separate the threads and they will convert into a like a cloth by weaving or knitting. So that's completely a dry process. If you come for the second process is wet processing. So where comes the cloth you see here in this picture, like the pinkish color, like like I have drawn something over here, right? Okay, so if you see here, you can check the colors of the garments would be little grayish, not purely white, but it will have some grayish color, light purple color. Okay, so then there comes our wet processing, where we need our complete processing, like a bleaching. We need to make them white. Why we need to make them white? Because whenever you go for a dyeing process, the dye may be blue or a green or a red, but the mixture of color shouldn't give some other output color. So we always prefer the cloth should be pure white. So that's why we process the gray cloth with a bleaching process, and we use a certain chemicals like peroxides and things to bleach them. Then after it gets purely white, then dyeing process will be happening. The dyeing will be not in a single process. They will have 2 times or 3 times or multiple times of dye. If you see here, there is a vessel. It's filled with a like a red dye, right? So that dyeing is also having so many process, like not a single process will do that. You need to work for it, like sizing, desizing, scoring, again bleaching and mercerizing, dyeing, then final finishing. So every time when you use this cloth inside your dyeing container, always it comes out with the wastewater. When you go for the first time, maybe the wastewater is very concentrated, and second and third and fourth or fifth time, the concentration will be somewhat diluted. But anyway, the concentration will be more. So what type of chemicals we use there? Okay, we will see this one in detail. Then I'll like just finish off this picture, and then we have our after drying processing, we'll have a process, other too many process to finally get a good fabric. Then it goes for the drying process, where we will design and measure and printing things will happen, stitching and finishing. Finally, it will be like a t-shirt or a shirt or a sari. So that would be the final product. Okay, wherever you have this wet processing, where I have shown you like the wet processing I showed you here with the bleaching, dyeing and finishing, this pinkish, this area covers mostly with wastewater, right? You utilize more water, at the same time we will dump with more wastewater. As I showed you in that report district, like in 1950, 85, it was might be a little wastewater, but you just imagine in 2005 and 2010 and all, there is a tremendous change in the increase in exports. So lots and lots of cloths have been produced or manufactured, and the dyeing process has happened. And you just think about how much wastewater created. So per kg of fabric, the wastewater created would be 120 to 150 liters. They're not going to be a pure white water. Actually, it's going to be a mixture of colors. Sometimes if they are doing red coloring or red dyeing, it will be a red, or sometimes it will be a green. So depending upon that, you will have n number of like mixtures of chemicals and dyings in the wastewater. So you can see this one collected from the industries. So it's purely from the case study. So I went there. I have seen all the coloring and things, and I have seen those chemicals they used: polyvinyl alcohol, methyl cellulose enzymes, and some caustic sodas, peroxide. So mostly inorganic ions and organic pollutants. Okay. Then go for this. And this is the wastewater that has been collected after the dyeing process is completed, and we look directly into this. So what I have done is I have taken some 20 samples from this, not only on this waste, dyeing industry. I have collected from several dyeing industries. I collected some 20 samples, and I have checked with the characteristics of the wastewater, like pH, total dissolved solids, BOD, COD, chloride, sulfate, sodium, and color. And I can see that tremendous increase I saw in the total dissolved solids and chemical oxygen demand, that is really coincide with the previous literature. So the major contaminant, if you look into that, it's going to be a textile dyes and inorganic like salts. So if you look into the why most of the dyes, it's not fixing with the cloth. Why actually we are dying, right? So 100% fixation should be there, but we get only very less. I say mostly 50% is washed away in the wastewater. If you look into the nylon, if you have a wool kind of sweaters, the fixation will be only 7%. That's why we always keep our wools and sweaters are very favor, like we won't put it in the washing machine because it will become very fade. 1 or 2 washing time itself, it will be all the dyeing would be washed away. Yeah. So most of the like the clothing fabric we use are cotton, linen, silk and wool. So that is very good in reactive dyes. Dyes also you have various types like acid dye, water dye, naphthols, disperse, direct and reactive. But we mostly prefer reactive dyes that's suitable for our fabrics, and nearly it's that is having a 50% fixation, like unfixation. So these things are like unfixation. Maybe the colorful sweater may have a 20% unfixation, 80% of the colors would be fixed. But we use reactive dye. Why we go for reactive dye? Because it's comparing to other dyes, it's not that much harmful, but still it has some harm chemicals and things. But the world level, if you see, nearly the reactive and dispersed dyes have been used half of the total one. And in addition to the dye, not only simply we put the dye in the container and the cloth, we will add up with some salts like Glauber salts. We call it them as sodium sulfate and sodium chloride. This helps to transfer the dye molecules to the fabrics. Okay. In addition to that, this happens only purely in an alkaline condition. Like your pH should be between very near to 10. Then only the dyeing process will happen. If is it acidic, then definitely your dyeing process won't happen. So we are making the the dyeing to reduce its acidity. So we are moving them to alkaline environment. Right. So, okay, once I got all my wastewater, I know what are the wastewater contains. So what about the treatment is happening for the wastewater? Traditionally, if you go for I hope everyone know about the environmental studies, we normally treat our wastewater. The basic thing is removing the physically what are the particles present, so that would be removed. Suspension by suspension process, if anything coagulation, you go for coagulation or flocculation process, and primary settling will be happened. If you have a major this is physical process, and then we go for any chemical process, so we mix with some lime or some other chemicals to go for the process. Then we go for a biological process. Yeah, finally we make the wastewater to disinfect. So add some bleaching or chlorinated chemicals. So then finally the treated wastewater would be not would be the same concentration it has in the raw wastewater, but it would be a treated one. So somewhat better than that. So this is a general conventional process, but we can't use the same process for our textile wastewater because the major contaminants here is textile dyes and inorganic salts. So this chemical oxygen demands is organic dyes that won't survive, that won't be easily removed by all these process, right? TDS and COD. So no significant, the main problem is color. The color may not, will not be removed by this traditional process. Even BOD method is not suitable because this textile dyes, in this dye, the microbials will be dying. It won't survive on that environment. Okay, what are the limitations of existing treatment technologies for wastewater? So if you look into that, these are some advanced like phytoremediation, AOP techniques are there, and still we have so many. So I'm not going to cover much on this. So we have several limitations on this existing treatment technology. So These are all not going to be our part of the presentation, but I want to show you how the textile wastewater got discharged. This is in China from 2011. Then they banned that industry. This is in 2018 at Vairapalayam in Erode, and this is some of the locations at Tirupur in Noyal. Right, so textile dyeing is a high polluting industry, and this is classified as a red category by our Central Pollution Control Board. And if you see the world level, international level standards, you could see the pH, TDS, BOD, COD levels. It's recommended by the international level. If you check with our Bureau of Indian Standards, it's somewhat acceptable. And we have furthermore standards. I'm going to skip this one. Okay, here comes our GIS. Okay, you might have asked me why you have taught me about textile wastewater and things. We need to go and learn for the background of the study that we need, why I need to go for this study, why I have to choose this map, where this map comes from, where I can get this map. Okay, this map work I purely did myself with ArcGIS software. Okay, so what I'm going to do here, I'm going to do a complete study like in Tirupur, there is a river called Noyal. I'll show you that one. Here goes. If you check in the graph here, in the Tirupur, you will have this blue line as a Noyal river. It's not a perennial river, but it's a seasonal river. Whenever there is a rainfall, then you can see there will be a water in this river. If you see in the Tirupur, most of the industries are located near to this river. What they have done is, till 1985, they started the textile industries, right? Till 1997, they dump all the wastewater into this river. Since the quantity was very less, that was not a big issue. But when they're increasing the before 90s, it was not an issue. But from 90s itself, they started looking into the river color was it's going to be the surface water was too polluted and it is colorful, and that disturbs the locals also, like their groundwater and surface water solution resources. So that was a major thing, and then they have constructed some treatment plants, common effluent treatment plants, and internally they constructed some treatment plants and they started functioning. Even after that, even the treatment plant, the treated water has been again dumped. If you say it, Nohel is not a river in Tirupur, it's a wastewater dumping place. And also they constructed a Varthapalayam dam here. It's a dam. Why they constructed is during rainy season, there will be a water so that can be stored and it will be utilized for the agriculture purpose. So they can make use of this water for further purpose by the locals. But due to this mixed water, this dam become a reservoir for colorful liquid and colorful waters and chemicals. So if you see the growth of industries, it's tremendous after 1989 and it is huge. You see that these are a number of units. Initially, it was less than 100. And if you see now at present, yeah, some other industries has been closed due to this environmental issues. But if you see there is a tremendous increase in industry. Okay, so if I look into this, I want to monitor what's happening with the water quality, like groundwater quality or the soil. If I want to know that, so I need a help from GIS, where my GIS comes. So in order to work with the GIS, so normally it's a place, Tirupur. If you see, this is the line. This is the river line that crosses from. It connects from from Kerala. It's like a Western Ghats. Okay, so this one is Coimbatore. If you see, the river starts from foothills of there is a Western Ghat hill, and there the water is very pure. If you see, it crosses the Coimbatore, it's very pure. But when it enters Tirupur, it started polluted by the textile industry. Until Varthapalayam, it's very bad, and it started flow through all over, and finally it enters into another a big river called Kaveri. Yeah, so the pollution is mainly in the Tirupur region, right? Okay, so to learn that, I say all these things after I just made a detailed study using GIS. Yeah, So initially, I was not aware of it, where it started, where the pollution enters, and how it has been. So what I started is I started preparing this base study map. Okay. So here you have a latitude and longitudes. Okay, right. You can generate this map feature using GIS, right? So if you see this one, clearly you can check the study area, right? Now I don't know where I have to choose my study area, right? So I knew the Noyal River flows from Coimbatore. It goes through Tirupur and Erode, then to another place called Karur. Okay, but I don't know the status of my river. But I have to work with what is the water quality or soil quality nearby. Okay, then what I should do. So the government, after some of the industries has been closed. If you see, after 2005, nearly 50% of the industries, they got a closure, like shut down, and they were very much strict. You don't need to treat the water. Please ensure there is ZLD, which is zero liquid discharge. There should not be any discharge from the industries to the like uh, uh, to the river. So that's the strict rule they followed. Then, and zero liquid discharge, they have us various treatment methods that we are not going to look much into that. So even in this zero liquid discharge, if you see, they are using some membranes, specifically multi-evaporator feed, and they use some RO membrane to make it clear, but still this one is a issue. High quality is expected to get the water from this level to this level. So to provide this, they have another treatment that has some cost. It's a costly process. Okay. So just I want to show you some pictures what happened to the Noyal River. Sometimes if it's a black dye, you will get black color. If it's a green, then green color. So every time you can see that. Okay. Objective of the study is you have to make a monitor the physico-chemical properties of groundwater and soil near Tirupur along the river basin. And we have to understand what is the current contamination status. There were some few studies, very limited studies. If you see, this pink color are the journal articles and some reports, and green color are some green PhD reports. They have very few reports. They studied about the soil contaminations. And even if it's a water quality, they have done enormous study on surface water quality, but no one has studied much detail about the groundwater study. I mean the quality. And government, they have some locations they monitor the groundwater quality. Okay, those are the sampling wells along our study area. Okay, the main objective is all about first understand. So I made a field visit. So whenever you work with a GIS application and you're doing any case study, any project studies, so please try to go for a field visit and collect data. That's really, really important, right? So I told you there is a Western Ghats that's called Vellangiri Hills. I started with the foothills of Vellangiri. Then I have seen some municipal waste are dumped at the outskirts of Coimbatore. In the Vellangiri Hills, I found the water is really very pure. I just checked the quality also was too good. And then some municipal waste are dumped in the Noyal River when the water flows out of Coimbatore. Then it started in the like a Tirupur area. You can see some industries here in the pictures. So lots and lots of water started dumping into the river. And this is the Varthapalayam Dam. I told you the reservoir. They consist of all the collection of chemicals here. This is the upstream. This is the downstream. Then the water flows and it drains into Kaveri. When it drains into Kaveri, I don't see any unusual things. It was too good. So what they have done is they have constructed this Varthapalayam Dam. They arrested the flow of Noyal River. They stopped here. Now the Varthapalayam Dam is not in operation. Once they have constructed, they just stopped it, because if they open it, automatically all the chemicals that were stored in the reservoir would be flushed away all the way and it may contaminate. So they stopped it. So if I see, I can consider 3 zones. One is from foothills of Velengiri to some place like Perur. This is a city of Coimbatore, and this is a place, Manare, where the Thrissur industry starts beginning. And this is Varthapalayam Reservoir, the dam. Then the places it reaches to Kaveri. I have clicked some pictures with the water quality. So first I started with collecting surface water, river bed sediments, because there may be some chemicals and dyes over there. Then the soil was also sampled. So especially the area I told you, Mannarai to this place where the industrial area started, and I found physically, I have seen some colors or the water it was too colorful. Sometimes I have seen a red color, blue color. Even while I was sampling, I have seen that. So I just wanted to go for a sampling, some location just out of it, not exactly to this. Maybe some dissipation of pollutant may happen. So I just wanted to cover this area. And also I included this one. So from there, I just fixed my, if you see, these are the locations, different locations I just went and I have covered. And based on that, I fixed my study area, right? So if I do any field study or something, I need to go and check with the field and where I need to work for. So always the GIS will give you the latitude and longitude, that the location of your project area. So based on that, I fixed my study area. So then after that, what I have planned is within my study area, I have chosen different groundwater like wells, uh, bore wells to collect my groundwater sampling. If you look into the PWD, like the government sampling points, it was just a very few in the Thrissur. I'll show you those points again one more time when we enter. So here, if you see, there are 35 sampling points. So this also you can play with the GIS. Yeah. See, 35 locations. One or two locations you can remember the latitude and longitude. But if I want to show you all this visualization, you see, you need GIS. So GIS will give you to draw your study area, or to visualize your study area. It can tell you about the clarity about the topography. You see, I have just layered a topography map here that will tell you where my river pathway or course, and there is a reservoir that is also layered with my study area map. Could you see that? And groundwater sampling points also, like based on the latitude and longitude I visited. So I fixed my sampling points, right? So then I have collected the samples. Similarly for soil sampling, I have just located the locations, nearly 54 in the agricultural land nearby the basin, right? This yellow highlighted points are soil sampling locations. Okay, then I have collected the water, like the groundwater. So it's purely from well. Yes. Then I have collected soil samples from the agri lands. Okay. So these are the existing like public work department groundwater sampling points. If you see, there is some green, blue, these are out of my study area, because I have to check close to my river, because the river basin definitely have the surface water is completely polluted. It has a detailed report and proof on it. But I don't know about the groundwater. Groundwater study is not available so far. And even if there are groundwater samples, they randomly pick up 1 or 2, 3 locations, then they left it. So I want to cover up in the study area. In the study area, I can see only 3 points. Yeah. This yellow and this green and this red, and other points are out of my study area. If I look into the data also not a regular one. If I say point 1, this red and blue, they are taking the surface water regularly. This blue is still 2012. After that, they didn't pick up. This one they are picking regularly. This one they are picking regularly. Just 2 locations. So that is not going to give me a current status of my surface groundwater, right? So then what I have located is what are the common effluent treatment plants. where they are located. Are they are near to the river or they are dumping directly into it? I just checked and I found all these things are in the upstream of my river, and most of this thing, Mannarai, East and Kasipalayam, Periyampalayam, CETP, those are all just within my area, like study area. There are 20 common effluent treatment plants. This also you can plot using GIS. And you can see the elevation data, you know very well about latitude and longitude, and also you need to know about the elevation. The elevation will tell you how about the flow of your water, right? So how the water will flow from westwards to eastwards, how it goes from one place to other place. So that can be done with the help of elevation plotting. So for elevation plotting, what I have done is with the help of a topography and your arches map and base map, the elevation was identified with the 3D Google Earth, and that will give you the exact elevation of every terrain or any valleys. So with the help of that, I plotted this one. I made a shape file and I have layered this one here. And you can see how it is beautifully uh, mapped or visualized. You see, the dark color gives you the highest elevation, and the light color, the like white, is having a lower elevation. If you look into the map, I mean like the study area map, I'll show you the initial one. Yes. So this one, if you look into that, in Tamil Nadu, the river starts from Coimbatore. Yeah, it flows through this and it enters into Kaveri. Then it Kaveri drains into the east coast. Okay. The flow would be this way only. Like the elevation will be higher because it's a Western Ghats, Coimbatore and all having higher elevation, and it moves in the east, the elevation drops down. This is clearly visualized in this, in this mapping using GIS. You see that 950, the highest elevation is 950 meter and the lowest was 752 meter. Right. And this one is about the land use map. This one also you can do by yourself with the help of GIS. Your field visit and satellite images and previous layers and land use pattern or like land use mapping and all, you can get it from the government websites or at the office. And you may get 10 years or 5 years before data, but current data you have to visit the field and check what is the updated land use pattern of the study area. That's very important. The green area or agricultural land, right? The green area or agricultural land, and the yellow are highlighted as a residential or institutional area. The reds are your industrial area, and the light blue I have highlighted as water bodies. And some CETPs, I told you some 4 CETPs are present over here, common effluent treatment plants. So they are located, and this is by purple color. And some barren land, it's not for agriculture purpose, but and some empty lands with some dots. So this will give you a very good visualization of land use pattern. And then this slide tells you about the details of study area. So not only your land use pattern, you should know about the soil pattern here, right? So what type of soil present? So if I looked into the previous year data, or if I look into the previous reports and all, they have a specialized soil series. Say for example, these are all Palladam series. This checked are Irigur series, and this is Vanapatti series, and this is Noyal series, and the greens are Tulkanur series, right? So these are the different series of soils. And what this series will have is, if you look into the report, they have all these things this one is roughly they have matched it, and I just find out the latitude and longitude and the location from the map. Like everything is like a theoretical data. I converted them into a visualization mapping data. So mapping is very important with the help of GIS. And yes, if you see the Palladum series, you have a conquer bed and dry brown sandy loam for first 18 centimeter. Then next is moist dark brown soil, then gravelly soil, then canker bed is about a limestone kind of thing. So what these series talks about the subsurface layer, different subsurface layer, but they have 5 different subsurface layers within this area. Why I want to study about this is the surface water may permeate into the subsurface, and that plays a major role in the groundwater contamination and soil contamination. To understand that, I need to study about the soil layer. So this one also you can so from the series you can tell what would be the top soil, right? So soil layer can be easily mapped. So if you see the pink one is dry brown sandy loam, green one is a dry and moist dark brown sandy loam, and this blue color is a dark reddish brown sandy loam, and this one is dark moist dark grayish brown clay loam. Okay, so there's whatever the theoretical data that can be easily interpreted into a visualizing mapping. And this is all about groundwater depth as well as the rainfall data. This is from Indian Meteorological Department. I just arrived this one. And after my field study, I've collected 315 groundwater samples, because each locations I collected three samples. So, and also several other points. And all those samples were like tested for TDS and COD, because that's a major culprit, the total dissolved solids and chemical oxygen demand. So that was purely detected, and I found the range was nearly 3853, So even if it is 264, we never go for the drinking water. I want to show you the standards. Let's have a look into the standards. I showed you in the first few slides. What would be the standards? If you see, this is a wastewater characteristics, right? So this is for if you look into them, the TDS should be, it will be higher, right? It will be higher for the wastewater. But when you look into the range, you see, it's huge, 16,670. This is for surface water. What I have shown you is the groundwater, but the values would be higher for a surface water. In groundwater, maybe due to permeation and things and the location and all, so it goes higher or it goes lesser in the groundwater. So since it's a groundwater quality, it's not similar to your surface water, but still this is not the acceptable range. Even in the groundwater, we never, I have compared this one with the groundwater quality. I'll show you those slides. And if you look into the COD, it's from minimum 0 to 384. So still it is not acceptable. And if you look into the pH, it's nearly 9. And soil samples have been tested. This is tested for engineering properties and physicochemical parameters, right? So engineering properties like bulk density, moisture content, dry density, I found the specific gravity is a little bit higher. That shows it's contaminated. And the clay, silt, sand range. And these are all about purely chemical, right? I found the EC range is high. EC means electrical conductivity. And pH is also, the soil is high. And total organic carbon is also it's too much. And I have done I used AquaChem software to understand and study about the anion cation, the contamination in the groundwater, as well as in the groundwater study. I found what would be the range and how it is accumulated, salinity hazard, and all I have calculated. And I have plotted them in the as a spatial distribution. So what is spatial distribution? So do you have any idea about what is spatial and temporal distribution or investigation? So spatial will give you all data with respect to a location. Yeah. So say for example, this is groundwater depth, right? So the groundwater depth, if I look into that, this one may be within 4 meter. If I look in deep here, it needs more depth, like nearly 8.8 meter I need to go for a groundwater. Here you see it's nearby surface, 4 meter. So depending upon the location, so your data has been spread spatially in the study area. So for the same data for groundwater depth, every locations I can tell what the value will be. This can be done with the help of your GIS. So that's called a spatial distribution. So this is about pH value. If you look into the pH value, this is high over here, you see, especially in the upstream to downstream nearby orthopolyme area, and it is low at the ends. So this tells you the more contamination happens, only these area. These are all for groundwater. And this is for TDS, like total dissolved solids. You can see high TDS observed here, and these are all the places where our Vartapaliyam dam, and here also some dissipations of these reservoir, maybe it has permeated to the groundwater, and these also other places where we can see higher TDS. And this one about chemical oxygen demand, that's purely about organic dyes, how it spreads from here to here. And you see the green one having no COD, which means the groundwater doesn't have any organic dye. But when you look into the dark blue, you can see the huge the accumulation, and it's somewhat intermediate value. So this is a spatial distribution of COD. And this is one for chlorides. If you look into the chlorides, so chloride should be normally less than 120 in case of groundwater, but you can see it's high, especially in the dark area. So similarly with the sulfates too. And this is about sodium. So why sodium? You remember the global salt I told you, sodium carbonate and sodium chloride, that helps in the fixation of dyes into the fabrics. That's why you have a huge accumulation of sodium, sulfates, and your chlorides. So those will be more. Those are all covering your global salt we use for our dyeing purpose to facilitate the fixation process. Okay, then you have a you have this one. This one is your sodium absorption ratio. So actually it should be very low. You can see how it is accumulated. The sodium got accumulated at various locations. And this one is all about, you can see from the, so if you look into this is sodium and this is sodium absorption ratio, and this is purely about the soils. So spatial distribution of EC, that electrical resistivity values or electrical conductivity value of the surface soil. So this is directly related to your TDS. You can see this is very huge. 4.6 is a highest value of TDS. So that is for purely soils. I have done sampling for surface soil and subsurface soil. For surface soiling, I have done for 15 centimeter from the top, and subsurface I have done for another 15 meters. So it was like a total 30 meter I have done sampling. So first surface to 15 centimeter was considered as a surface soil. And the next depth below 15 centimeter to 30 centimeter was considered as subsurface soil. Just I want to just see how the permeation of the contaminants. Why I have to look for is when I was doing the sampling and I was looking into the soil, there is no way that the water from the groundwater that can permeate and come into the agriculture land as a source. But I have seen there is a culture there because it's a seasonal river, and the farmers, they want watering their agri land. What they go for is they use the groundwater or surface water for their uh, like for watering their agriculture land. Especially they go for surface water. Sometimes the groundwater will be very low, and they couldn't afford it. At the times, they make use of the surface water for their if they want to watering their plants in the agriculture land, they utilized. That's why the surface water has been utilized for the agriculture land, and all the contaminants got accumulated in the surface and subsurface soil, because there will be no other ways. Because I have seen most of the wells you have seen, they're all covered with a impermeable layer, like a confined strata, like hard rocks and hard gravelly or hard rock bearing stratum. So the only way they can do is the permeation will be there, that will be very less, but the most of the thing is they utilized the reason behind the contamination is they utilized the surface water for watering their agri land. All right. So this is about EC and this is about TOC. TOC is your total organic carbon. This is purely for this denotes the organic dyes present in the like soils. It's because of the surface water they have utilized for agriculture purpose, and that contaminants get accumulated in the surface soil. If we look into the values of the surface soil, 4.6 is EC, okay, and this is 7.4% for total organic carbon. If you go for the subsurface soil, the EC is not 1 point, it's not higher than surface. Surface was 4.6, here it is 1.8. Yeah, and also the same nearby locations. And also here, if you see, TOC is 7.4%, but when you go for a subsurface, TOC is 2.97. It's lesser than your surface. So the permeation plays a major role. Okay, then I have identified the major locations. I want to check with the temporal variation. What do you mean by temporal variation? So spatial investigation or spatial distribution means, like, with respect to particular location, the data will be like investigated, like with respect to location. Say for example, this location, I have a less TOC. This location, I have a high TOC. This location, no TOC. So with respect to a location, I'm spatially distributing a data and interpreting and analyzing the data, right? That's called spatial distribution. If you look into the temporal variation, I pick up any of this like locations, and I'm just looking into the various time period. Say for example, in 2015, 2016, 2017, 2018, there may be an increase or decrease with the data. Since it was a 3 years data, you couldn't see much changes. But if you, for the same location, you can get from 1990s, like 85, 90, 95, 2000, 2005, 10, 15, 20, 25 till date. You will get a tremendous change in the TOC. Like initially it was very less and it might have spiked and then gradually decreased, then constant kind of. So since it's a limited duration, I could get only a constant data. So these are the different locations where you can get a data with respect to time period. So temporal is nothing but it's a time period data that you don't need just for this, just you can do with your normal plotting. But the investigation is purely spatial and temporal variations. Yeah. And you can see this similarly for pH and similarly for TDS. Yeah. And you can see for COD, chemical oxygen demand. If you look into the pH initially, if some location is 9, it's maintained the same. So there is no reduction, nothing, just same thing happens. But they didn't increase it because already they polluted the groundwater. If you look into the TDS, you can see there is some changes, minor changes. Maybe some reactions, or maybe the precipitation, like the rainfall may diluted the the groundwater. That might be the possible. So that happens. And if you see the COD, initially it started reducing, but I can see a spike over here. This is because at that time I have seen some of the wastewater was illegally dumped into the river. Here you can see in this location, it started reducing. Maybe if you leave it for a while, naturally there will be a reduction in chemical oxygen demand and other things. Okay, this is the final picture of your study area where you have all your locations, like sampling locations, and you can check with your drinking water quality, compare the characteristics of sample data, and you can tell whether I can use this groundwater for drinking purpose or not. Here the locals, they rely mostly on this water, because during rainy season, this is the only way of surface water source. This surface water source only recharges the nearby groundwater wells and other things, maybe the natural rainfall. Other than that, they don't have groundwater depth immediately. They have a higher depth in their locations. So for them, this groundwater should be a good source of drinking purpose, but it is not. You see, the locations they're having a cross, I have seen those are all beyond the desirable or acceptable limits of drinking water standards. Yeah. And here are some are good, but other than that, so if you see even the picture, the visualization showed you the dark colors and higher values over only this area. So downwards and downstream side, you got the accumulation of the chemicals or the pollutants. Okay. So this study, this conclusion you can get only after mapping all the data in a single GIS map. Only with that investigation only you can conclude that, okay, these are the area I have to be very careful. I shouldn't use those groundwater. I have to go for some remediation. So that's very important. So only with the help of the spatial study only I can identify that. And here also, this is for irrigation purpose. Okay, that's not useful for drinking purpose. What about for irrigation purpose? Whether I can I go for irrigating the nearby agriculture land? So that would be helpful. So whether I can go for it. So again, I checked with the properties of those collected groundwater for a irrigation standard, because in irrigation standards, you have sodium absorption ratio, salinity hazards and other things, right? So I checked for that. And here you see the flag type things, like purple flag. They may be utilized for irrigation, but not for drinking. But this cross is purely not for irrigation also. It's highly polluted. It's not even comes under irrigation purpose. You can see that. Okay, this is for the soil, checking the suitability of soil for agriculture purpose. And the green color or the surface soil, because I have collected both surface and subsurface soil from every locations. But I want to check whether these surface and subsurface soils are suitable or not suitable for, whether it is suitable for agriculture or not. So the green ones are the suitable and the red ones are unsuitable, right? It's not fit for agriculturing purpose because they are already contaminated with high TDS and COD, right? If you look into the soil, just nearby your surface water, right? They got contaminated. Maybe these area water, surface water might be utilized for the agriculture purpose. That's why that contaminated directly or indirectly or the agriculture land soil. And this is again, those are all, these are all for surface soil, and this is for subsurface soil. When you compare these two graphs, see, only mapping helps you. Just because of ArcGIS only, I could easily relate these two things because visualization is very easy when you incorporate the data into using ArcGIS, right? GIS. So if you see, the surface soils are more contaminated than your subsurface. Subsurface, only very few places I could see the contamination, maybe because of the soil series I have to look for, and the permeability must be high. That's why it get permeated to till some 30 centimeter or 25 centimeter. But when you look into the surface is highly contaminated, but surface is somewhat better than that. Okay, then this is the comparison with the historical data. So the groundwater samples. I have picked up the locations where I have some data in 2001 and 4. I have some data, and also I have given you all the informations like where I have collected the data and everything here. If you see, so the single star is the Madras School of Economics. They initially made a field study when they have constructed, after constructing the Vartapalayam Dam. After 2000, it was a serious issue. It was a serious issue that they have to conduct like a study whether the Noyal River is contaminated or not. So after 2000, it was a big issue, and the court ordered the experts to make a study on the location. So they collected some samples in 2002, 2004. This is PW data, and these are all PWD data, and this is the study data. So I just checked, compare the locations, and for the same locations, groundwater, if you see, the Vartapalayam, it is increased. The pollution get increased, you see. And this is Kadhankani is increased. It is 8.1 pH, but it is now 9. These are all groundwater samples. And another Tipampalayam, you see there is an increase and it's in the range. So these are all compared with the historical data as well. And this one is for soil samples. If you look into the soil samples, here you can see I have a 1967 data. This is from land use organization. They have the historical data, and if you look into deeply into that, they have done only for pH, EC and all. They calculated after 2000 only. I don't find any data on EC. So those locations, they have already found the pH. pH, you see, it's very less in 1967. I have shown you the industry started in 1985. And you see in 2000, 2017, this is for surface soil, and this is for subsurface soil. Yeah. And you can see the pH is very high when you come for the study. So I just compared that, and I found it's injurious to most of the crops. I talked with the local farmers about the trend of their groundwater and agriculture activities. They said like before 1980s, it was too good. They have a wonderful agriculturing, like they were growing rice, wheat, and other crops like millets and all. But after 2000, they started changing the crop pattern because the soils, they whenever they wanted to water this, the agricultural land, they utilize the surface water, and automatically the fertile land becomes like a it's a like it's not fit for their was not fit for their agriculture purpose. So what they have done, they changed the crop pattern. They changed to some other crop pattern, like instead of that crop, they go for cash crops. Cash crops, like instead of rice and millets, they went for cotton, like a cotton plant, and other different like nuts, like peanuts, groundnuts they used. Nowadays, they don't go for that as well. They are just utilizing the land for growing some plants for to feed their cows and the goats, and also they just using, it was not actually utilized. Yeah. So their agriculture practices got gone down because of that contamination. Even about the groundwater, I asked them, they said initially they were utilizing the groundwater directly from the well and things. It was too good. Nowadays they have to they have to walk for some several kilometers to get a liter of like a pure drinkable or potable water, groundwater, drinking water. So it's become a burden for them because these industrial growth, actually it's polluted the environment. But we need to know what's the situation, current situation of the location, where the points, because we knew all happened because of urbanization and industrialization. That's okay, but we need to remediate it. We have to restore it. The environment should be remediated and restored. So to do that, your main objective is you need to know the physical chemical properties of those locations. That's why where our objective plays a major role. If you look into the previous slide I was talking, now it might be very familiar to you, like now what I'm meaning, like to monitor the physico-chemical properties of groundwater and soil at Tirupur along the Nile River basin. And we have to analyze the current contamination status. People are telling it's contaminated, but what the location? Which location has more contamination? Where I need where the accumulation of the pollutants is more. So that one should be done only with the help of um, your detailed ArcGIS study. That's very important. Okay. So I think now we arrived at mostly the conclusion of this topic. So we found what are the locations where the groundwater is not suitable for drinking and drinking purpose and also for irrigation purpose, surface soil suitability for agriculture and which is not fit for agriculture activities. And also we compare the data with the historical data, current data, and we arrived at a conclusion. Yeah. So the conclusion is the physico-chemical properties of groundwater and soil at Tirupur was monitored, and the current contamination status due to past past industry activities has been analyzed. And I found these are the wells are highly contaminated. Temporal variation is nothing but with respect to time, how the pollution gets changes, the contamination concentration gets changes. So this one we found out with the help of temporal variation with respect to time period, how my pH, TDS, and COD get changed. And most of things gets diluted, right? It's slowly, naturally, it's back to its form. It's just going towards its natural state. Only 29% of the groundwater fit for drinking purpose, whereas 71% show the presence of high like chemical oxygen demand, that's organic dyes, and found not suitable. For irrigation purpose, 54% of the sample are high salinity risk and only 29% fit for irrigation, whereas 17% may be permitted. Also, in case of agriculture soils, certain locations confirm that 61% of surface and 20% of the subsurface soil are not suitable for agriculture. So with all this study, what we can identify is I have done a field study, detailed field investigation, then collection of samples, like locating your location, like sampling locations. First, you have to fix your study area, then fix your study location or sampling points, then collect samples regularly. At least I have done for nearly every monsoon, pre-monsoon, monsoon, and post-monsoon. So I have collected the samples accordingly, continuously 3 years. Maybe if it's going to be your current study or project area, you can continue till date like that, like continuously you can monitor that. Then after that, I have collected all the samples regularly and characterized and compared with the existing standards and procedures. Then I started using the software to visualize the data, visualize all this data into the study area so that I will get a spatial distribution of complete idea of water quality and other things, right? Now coming back to that introduction slide. So what I have taught here, like we were talking about, it's about the collection of data, right? And there are some procedures, standards, like characterization, comparing with standards. I need all just software, yeah, and hardware like computer, networking things, and expert. As I'm an expert in that, so I could talk with, I can do some literature study, and I can contact some experts to work with it. So these are all plays a major role in your GIS. Yeah, Geographic Information System can use similar kind of so data is very important. Any kind of, you can use such GIS application in any kind of projects. It can be a traffic, or maybe urban planning, or maybe finding a location for municipal solid waste disposals. Where are my bin locations? Where are the collections are happening? Where the collections are not happening? So all those things you can clearly picturize and visualize with the help of GIS. So GIS is everything, and lots of projects works are piling up now. So anyone could take up, and you can go through with the go every projects with the help of GIS. That's very important. Okay, then I have published my work. This one in GIS-based spatial and temporal investigation. This one in a SEA journal long back. So these are my publications. So out of 11 publications, 9, I was the principal, I mean like the corresponding author or the first author. And these are some of my conference publications, and I was granted for a patent which I was working on during my research, and these are my book chapter and book publications. Any other doubts you have? I think we can conclude this presentation. If anything you want more than that, and also if you look into the like I have worked so many with GIS, but this is one of the case study I would like to share with you all. If you want to discuss anything other than also this project also, you can discuss with me. So I think I can stop here. You just let me know if you need any clarifications what we discussed before. Thank you.
Participants can either unmute themselves and ask the queries, or else you can post it in the chat box.
Okay, thank you, Professor Manavalan. I can read your message. Okay, thank you. Thank you for your appreciation. Any other doubts or clarifications? In addition to my presentation, I'm glad to say I'm a DAT scholar, and I'm also a Felix scholar in UK. I worked on several projects. Maybe I can take 10 to 15 minutes to go along with that. If anyone interested, you can just look into that. Shall I continue, ma'am? Or I have to stop here?
You may continue, ma'am.
Okay, right. Is there any time bound, like I have to stop by 3 or 3:30 or anything like that?
No, it's okay, ma'am.
Okay, right. So do we have students also as a participants, or only the faculty members, ma'am?
We have only faculty members. Most of them are faculty members, ma'am.
Okay, right. Thank you. All right. So you have an enormous opportunity in like working with the GIS. Okay, I would like to share my experience when I was working in Cape Breton University, Canada. I think you can see my slides very well, where I was working with the mine water management. It was a Cape Breton University. It was located in an island. If you see, it is exactly at the end of the Atlantic Ocean. Like after this island, you can see Atlantic Ocean. So the ocean water it's actually covering up this island. Okay. So what happened is the history of Cape Breton is like they have done n number of mining. Mining was their activity for last 200 years, but they closed everything after that. So tremendously, they exploited all the mining things, and they utilized all the resources, and they found the gallery, like the mining area empty. So after the mining area get empty, all the water get oozes into it, and their groundwater gets suddenly increased. And they found there are some places there may be oozing of groundwater, and that is also colored, like colored water coming out of the ground. They closed the mining, and they had some clock and things, like they closed it, but they don't understand what these water. First they picked up the water, and they make up a simple wastewater setup like what we have done. And they found initially the color was like a orange color, like a red soil color. And they have reduced the colors and contaminations initially, but after some times the maintenance is not proper, and still they got those colors coming out. And they check the water is not purely salt water, because it's not water from the surrounding thing, but it's purely groundwater get permeates into the mining area, and that is oozing out through the surface. It was a really challenging experience, and I was called for working on that project. They wanted to know where the location, which location, what is the reason they got all these things. So I have already studied their mine maps. Yeah, so the mining area and maps. They have several galleries. And I worked with another software, and I utilized this ArcGIS as one of the software for mapping and other things. I have published this work as in a conference in US. So predicting you can check on my Google or something, like you can get the topic, like predicting the geochemical changes of those groundwater, what happened and all. I have done it. So for mapping and other things, I used this ArcGIS. It was really helpful. It was in, I think, 2012 and 2013. I have done some work, and I just presented that in US, and it was really useful. So at the time, ArcGIS was new to me. Then I utilized that one for my further research and things. So that was a quite useful work. I think that's application of my GIS. That's what I want to say. Then other than that, if you want to ask me anything, not only with the presentation or anything academically or research experience, anything I'm ready to share. Please feel free to ask me any questions, or just if you don't want to talk on the forum, no problem. Just you text me in the chat box. I'm just reading the chat box. You can throw me some questions if you are interested. Thank you.
Any queries from the side of the participants? Okay, so shall we wind up the session, ma'am?
Yes, ma'am. Yes, ma'am. No problem. Thank you.
Okay. So, good afternoon, everyone. Today, I have the proud privilege to deliver the vote of thanks for today's enlightening session. On behalf of the entire organizing committee and all participants, I extend my heartfelt gratitude to Dr. Chandra Devi R., Associate Professor, Sri Krishna College of Engineering and Technology, Coimbatore, for her insightful presentation on GIS-based case study in Coimbatore. Now, we have in details explored the spatiotemporal analysis using GIS tools to assess the soil and water quality, not only academically enriching, but also practically relevant, especially in the context of environmental sustainability and industrial impacts. We are grateful to you, ma'am, for giving us such a wonderful session. I also use this opportunity to thank our faculty members, participants, and the entire organizing team for making this FDP. Your engagement and curiosity has added great value to our session. Let's carry forward the knowledge shared today and continue to explore more ways to protect and preserve our natural resources. Thank you all. Once again, we'll meet tomorrow with yet another session. Thank you, ma'am.
Thank you, ma'am. Thank
you
you.
all.
Thanks to all participants. Thank you for your time. Thank you.